Hello everyone, Eyal here. Hope you're all having a good day, good weekend. Just calibrate things here, calibrate the mic, calibrate the camera position. I'm having a weird hair day, I don't know why. All right, so how's it going, everyone? This is going to be another one of my learning experiences where I'm working to learn all kinds of things about games and computer graphics, and just writing my own little wrapper around them in C++. And the idea is I'm going to be I'm just going to be going through things that I know because I'm pretty good at C++, but I'm going to be using Google and ChatGPT to learn things about OpenGL and graphics, and just implementing my own little wrapper around them, which I've started in the last few streams. As I usually say, first of all, I don't know, you could be watching this on YouTube, you could be watching this on Facebook, LinkedIn, X, Twitter, stuff like that. And wherever you're watching, you feel free to comment, and I would try to bring your comment on screen. It's possible, at least on some platforms, so that everyone else can join in. Feel free, if you're wherever you're watching this, to follow, subscribe, if you want to do that. And hopefully the AI music is audible and not super weird. And let me get my setup up and we can go. So how's everyone doing? Hopefully, let me know, if you have any questions for me. People know me usually from all my music endeavors, playing keyboards, arranging, coding music software of sorts in different ways. There won't be much of that today, but we can also discuss how things I'm doing relate to audio and what is the purpose of learning graphics like this. So currently my little window wrapper from previous streams just does a triangle. It is a nicer looking triangle than last time, I think. You can see that it's animating, it's beautiful. And there is a little abstraction library here that I wrote, which I'm going to be improving over the stream. Yeah, so this is what we're going to do today. I'm just going to respond to somebody about something, and then we can get going. Hopefully audio is okay, by the way. Okay, so what I want to do now, there's a few things I want to do. The main first thing is I want to, I have this little abstraction here. Let's go back to where my abstraction, my game, let's call it, calls the abstraction. It's still pretty raw. There's just things here that are actually like leaky because the shader is actually passed into the game. It's probably not ideal. But the idea is now this is the, let's call it the game code. Which is abstracted from this whole system of, of SDL and the, like for example, by the way, my namespace now still says SDL, so I'm going to change that. That's going to be fun. Let's see if CLown can do this across the whole code base. I'm going to start with something like, let's not call it SDL. Let's call it, probably need to add more namespaces here, but let's start with something like engine. Yeah, let's call this engine. Engine is a little better. Let's see if it can do that without changing unrelated things. Okay, that'll be a better thing to call it. Good. So it still compiles. So let me commit this and see that I changed namespace to engine, because it's not really SDL. SDL is more like an implementation detail. There's actually no SDL in the user code here, and it can actually be used with different backends, not just SDL or OpenGL. Okay, so this is I guess the initial data. That is that when I call it, I abstracted a lot of the OpenGL ugliness. There's a lot of OpenGL ugliness there, and I'm hiding it because, first of all, it's very likely that I would be using something like Vulkan later or something else than OpenGL. But I also wanted to have like some uniform call site where the call site is more expressive. There's not like, if you'll see what the shader program does, there's a bunch of like, setting up the OpenGL stuff, attach shader, link program. Like, it's a bunch of steps that I think need to happen. And I'm trying to combine these steps to something more ergonomic. It's still pretty raw. Like, ideally, maybe at the end I'll find a way to also abstract the shaders. Not sure if I can do that, but maybe. Because I would like to have much less interaction in user code. I'd love to create some expressive thing where you're describing the shapes. And here I created this thing called a triangle, right? Engine triangle or something. But ideally, then we can start making stuff like more complicated shapes that are built here. So the one thing I wanted to start is I want to learn more. Maybe this would be a good time to interact with something like ChatGPT. I want to ask ChatGPT about whether my next steps. So let's see if it's gonna know something about my next steps here. For example, let's ask it. Let's ask you something like, okay, so let's try the preview one, see if that works. I'm working on a wrapper around SDL and OpenGL. in C++. I now have user code that can add triangles and draw them on screen. Maybe I'll even give it an example of how my code looks like. And you might want to see my shaders as well. This is an example of a of user code that calls the abstraction layer. That works, and I have an animating triangle. Now I'd like to move forward with other shapes. For example, how would I describe a rectangle in this situation? Let's see what it's going to find out. What it's going to do. Oh, I got 2 responses. That's interesting. I'm giving feedback. I've never seen that window, but ever in my life. Rectangle. Oh my god. How do I even handle this? The 2 approaches. Oh my god. Which one do I prefer? So a rectangle is it? I could use 2 triangles since open triangle. Suppose of 4 vertices, which can be split into 2 triangles. Okay. So the idea. So their idea is they have a struct with a vector. Yeah, that makes more sense. Like 2 triangles, not have a vector. Vector is kind of weird for this. So let's say I prefer the left response just for clarity. Okay, that's good. So it says that the rectangle class yes, that definitely looks better. So I'm creating a class called rectangle, and then oh, here it is, add to shape. That's interesting. I don't love the idea that I'm storing it as triangles. Maybe what I would do is I would store it as a rectangle. Yeah, let's ask it to do that for me. Great. Can we store the rectangle as a regular rectangle with X, Y, W, H, and only convert to triangles with a member function whenever needed. Okay, here you go. Let's start to look better. Let's see this beautiful rectangle class and see if anything that ChatGPT did make sense. So where I have the triangle class, let's add a rectangle class. Oh, it might need to know about shapes. So let's put it right here. Here you go. Bottom left, bottom right. That looks good. So when I do, yeah, let's just add to shape. Or maybe I'll do the other way around. I can do that, the class rectangle. Yeah, maybe I'll change that a bit. Let's do that, and just say that if I add a triangle, it looks like this, and if I say an add, if I add a rectangle, then rectangle, and I can just do add. Oh, wait, he didn't do what I want. No, that's not what I want. Okay, so that's how you create them. Okay, that's the idea. So I need, yeah, so I do need an add to shape, but I think he misunderstood what I needed. What I told him, what I told it, is that this needs to be stored as bottom left and top right. That's interesting. Okay, so yeah, I probably just need to have these as member variables. Do I love the idea that it's stored like this? I'm not sure. No, you know, I'll ask ChatGPT to do that for me. Let's see. So, okay. Oh, so I did have an option to do this, right? Okay, so maybe I missed. Yeah, let's try this. This class. Let's see if it understood what I need. Okay, this is better. 2 triangles. Okay, that's nice. 2 triangles. Think of the best way to do this interface. This is a little optional function to retrieve triangles without adding them to shape. I don't know if I need that. Maybe. You know what? It's not so bad. I could probably think of a better way to abstract this, like maybe using some generic way to without. But I don't love the idea that it creates a vector, because this actually might be called often, because this would allocate memory all the time. I'm going to start with this, but this would require a little bit of. Yeah, here's what I might do. Do I have a CPP file in here? I don't. So let's create a CPP file on this, because I think this is going to be a useful thing to do. I'm going to create something called geometry CPP file. I'm going to add this to the build. I need to switch this to do Unity builds soon, so there's a single CP file. I might do that. Yeah, that's better. Let's include the header, geometry. Let's namespace this. And then yeah, I can require something like this, because I can probably do this some of the stuff in a more efficient way. So I'm going to start with yeah, I'm going to start with just something like a, I don't need another namespace here. I just need something like a struct shape forward declaration, and then I can just do this. It's actually possible that I should. Shape is incomplete, and it's because. Oh, okay. There's some namespacing happening, because now it's going to know what shape is, and it's going to be fine. So, and I can actually do the same thing with this. Like this might be a use case for something like a base class or a template, so that so each shape can add itself maybe a template would be better. Yeah, template would 100% be better here. Instead of have a base class that's gonna just create a V table, which I do not need here, probably. So what I could do is I can do something like this thing add to shape, and I can add the same thing to the triangle class, because I might have more interesting paths and stuff like that. But let's bring the for declaration of shape to the top. And all I need to do is make sure that the definition of this is in a CPP file where shape is known. So for example, when oh, here you go. So these are already vectors of, yeah, so they're already points. This is fine. So what I can do, I'm going to do something like interesting with this, like templates, type name T, and I'm just going to add a T, let's call it share, object or something, and then I'm just going to do object add to this, basically. And the implementation would be in each of the shapes. That will allow me to create, polymorphism here and a unified interface without doing any kind of base class. It's a very useful technique. These are not default initialized. I hate ChatGPT's coding style. Float height equals 0. Yeah, I also probably need, a default constructor here for an empty triangle. Yeah, so here, this would just do something like shape points. A, B, C. Yeah, can this change this? No, it's not what I want. Does it allow me to change it like a different style? No. Never mind. I can probably change it later. So yeah, so the idea is that this is actually useful because I might very likely would need those to be, maybe this is good because these are actually things you need in a rectangle. So instead of doing all that stuff, let's just do something like point get bottom left. Turn this. Get bottom right. So these are really useful stuff on triangle. So I don't want to just put them as x plus y. Let's put them as implementation details for that function. I want to expose those for logical users of these rectangles. So what do I have there? Other top right, get top right. And get top left. So this is like O2. Bottom left equals get bottom left. It could just be like this, get bottom left. Get bottom right, get top right, get top left, get top right. I can just remove all of these. yeah, and this would slowly will be the way I would hope that these classes would be eventually used by people who are, by users, not people, who are creating these different triangles. Yeah, so let's see if that works. Let's try to do the same thing that I did before, because there could be other bugs in this code. I don't know if this code actually works so well with two triangles, but we're about to see. So let's say that I'm going to go to my let's call it game, and instead of creating a triangle, I'm going to create a rectangle. So rectangle. It's going to create a rectangle with, let's do something like 0.1, 0.2. I want to see it. 0.2, 0.2, 0.6, 0.6. And then I want to add the rectangle. And let's see if that worked, if I have any idea what I'm doing. Okay. Oh, right, I forgot. It's not 0.2. It's the code. I forgot that OpenGL uses minus 1 to 1, so the numbers are actually wrong. I probably need to change it. So what I probably need to do, I really kind of want all the logical classes of mine to work with 0 to 1. So, but this looks good, right? This is an actual triangle. So let me commit this and say something like added rectangle logical class rectangle. Okay. Now what I'll do is I would like to I think that what I can do is that this draw thing. Yeah, I think what I'll do is I think whenever I do this, let me think about this, because that would require me, I need to think of the storage mechanism here. Yeah, okay, let me think about this. Yeah, what could be good is that I can right now. Yeah, this is also leading to another optimization of how this is held. Currently, this thing called the shape buffer does not have the shape in it, but I probably do need to have the shape in it, and also use that information to scale maybe into the parts that I need only when I'm setting a new shape. And that could also allow me, when I set this, to observe if this is maybe I guess the same shape or not, right? Yeah, this could be interesting. Yeah, because then if it's not the same shape, I can just draw. I don't need to do the whole buffer binding. I can just draw it. Okay. I think that would be good. So what I can do is I can just do something like a shape. I can store a shape here. Stored shape or something. And when I get a new shape, now I'm not going to do this optimization yet. I'm just going to do something like stored shape. Shape. Okay, now let's change this for the const. Does not need to be const anymore. Shape. Here I could do an optimization where if it's the same shape, just do nothing, basically. Ignore the kind of, do not do all this data buffering stuff. Or maybe it's always needed. I'll need to think about this. Yeah, it might still be always needed. I'm not sure. Anyway, so this is just going to be, this is not to be const, but this needs to work with the stored shape. And here, stored shape. Yeah. And I think the way I would want it is I also want to take a chance here to readjust the points. So what I'll do now is I'm going to, let's call it, let's have a function on shape called scale. It's more like so can I use, there's a C++ function, I need to see if it's available. So like std_lerp. I want to see if what is the there's this function called std_lerp. It's C++20. I can definitely use that, right? Yeah, it does exactly what I need, right? It's std_lerp. What are the oh, maybe it's not what I need. I need a scale from in a range. Right, let's see what the best way to do this. So in C++, I want a function that scales a value from a given range of min max to the target range of min max. It should look something like scale float scale float value float source min float target min float sorry, source min source max float target min float target max. All right, so they just wrote me the scaled float division by 0, blah blah blah, sort range. Okay, so is I'm surprised that that doesn't exist in standard C++. Anyway, let's just write it here. Let's call it math, namespace math. Also, this probably needs to be a template because something like that, right? Value, min, okay, good. So that means that when I'm working with this, I want to be able to do, yeah, I want to do like I want to scale the entire shape basically, so that I can copy this and then do something like I need a way to scale a point. That's also going to be useful. So let's do something like scale, float min, source min, float source max, float target min equals float target max equals 1. And then just for O2 point. Sorry, this is the 1 point. So I just need to scale x min source max, target min target max. Sorry, x equals. No, what did I miss? Source min, source max. Oh, math scale. Okay, good. So x, y, z, y, and z. Good. So this would scale a point, and then I can just do the exact same thing with the shape class, just a vector of points basically. And that would just go through all the points and then do point scale min source max, target min target max. I don't need these defaults, they make no sense. Let's remove these defaults. Okay, so I wrote the scaling function, and then I'm going to just here, right when I'm storing this, I'm going to also scale it. So store it and then stored shape. Scale from 0 to 1, from 0 to 1 to -1 to 1. Because these are the OpenGL coordinates. Let's see if this works. And I didn't miss anything. Perfect. Look at this. Look at this beautiful rectangle. Looks great. I like it. It's flashing. Good. So that allowed me to create my little game code something between 0 and 1 and have it scaled only in the OpenGL backend, which I don't know if all the backends actually use the same scaling. So that's going to be useful eventually when I create more backends, like Vulkan or something. Maybe the scaling will be needed, or maybe it will work to another value. So I like 0 to 1. I think it's more uniform. I like 0, 0 is the top left of the screen. So I think this makes sense. Like this looks pretty good. Sorry, this is my rectangle, right? 0, 2, 0, 2, whatever. And let's try. I'm just going to commit this and just see that I'm getting everything to work. So first of all, I'm going to say added scaling functions to scale 0 to 1 values to -1 and 1 for OpenGL. And maybe we can do something fun. So right now I'm doing the alpha change. Maybe I cannot do that. I can remove that for now. And let's just try to let's just try to do something like move this rectangle, right? So right now what I'm doing is, so I have add here, by the way, to shape, but I think I need clear. It's important. So the idea is I want to, for example, let's make this window move over time. Right now I'm still using the update function that I'm getting constantly called with as a almost like a timer. It's not the most accurate timer. We're probably going to go over it, like how to deal with timing. It's going to be the fun part of making a game, I think. But let's do something like okay, let's do something like have some animation happening. So I'm gonna do something like move. Can I? Is this all? I don't like the idea. I think I should make this a struct. I don't like the idea. This is public and private members here. Oh, and I definitely don't like this. Oh, this is a leftover from horrible ChatGPT stuff. Yeah, let's remove this. Let's remove this. I have such a nice interface here, and I'm going to keep it as such. Yeah. Okay, good. We need to compute triangles here. All right. Let's do something like, I'm going to store the rectangle here. So rect. Let's initialize it so that it has these initial values, but probably not the X and Y. Actually, why not? This is okay. This is actually okay. So let's move the triangle around instead of because what I can do now, for example, is I can create a shape on the fly. Might be good if I pre-allocate it, but it doesn't matter probably for this. This is going to just allocate memory, which is maybe not the best, but it's such an easy optimization to make, so I'm not going to worry about it too much. I'll worry about like writing the simplest code. But I do want to store the state of the rectangle because I don't need any of this constructor stuff now. What I do need is that in my update program, I'm going to do, let's even do something like that, like something like shape, get updated shape. So this is just going to be something like get updated shape. I don't even need to store this, but I do want to, every time that I'm getting called this, I just want to move the rectangle by a little bit. So it's going to be something like so this is going to be fun. Let's do something like enum class direction. It's going to have something like down, up, left, right. And then I'm going to store the direction that the animation is in. Equals direction down, for example. And then here what I'm going to do is I'm going to switch on the direction. Let's have it autocomplete the cases for me. So if we're going down, then rectangle dot y plus equals have some let's do something like auto speed or offset equals something like that. Oh, who knows if it's a good feed, but just offset if rect y is bigger than, and also let's do something like a limit. But it's gonna be, you know, if it gets to 0.8 or something, then y equals 0.8. So limit it to that number, but then direction is going to be, so we went down, then we're going to go right, direction right. Now let's do the up case, break. Let's do the up case. Up case is so for the up case, I'm good. Sorry, no, not up, right. Let's do. So right case is going to be minus on the x, plus on the x. And then if x is bigger than this, limit it and go up. Now let's do the up case. I'm going to go with y. Up case is a minus, and it needs to be smaller or equals to 0.2. And then go left. In the left case, it'll look pretty much right like the right case. But it's going to be minus. And then smaller or equal to 2.2, and then go back down. Okay, and then all I'm doing when I'm finished with this is go to shape equals engine shape. Shape, add rectangle, return shape. Let's see if that works. Okay, I made a mistake on my coordination because why am I going that far? That far to the right. I just didn't think of the number so good, but it's definitely moving. I'm definitely animating a rectangle. Let's make the numbers make more sense. Let's maybe just start with 0. I know why I didn't start with 0. I know why it made sense for me to not do that. Let's where's my initial rectangle? Let's start with 0, 0, 0, size okay. So when I actually go right, I should actually, yeah, my numbers don't make sense. I need to go with y until it's minus 0.4. When I go down, go up to 0.4. When I go up, yeah, 0.4 should be that. Let's do something like limit y equals 0.4. Technically, the limit y is basically just 1 minus rect width. and limit x is minus rect. Oh, the other way around. This is height. This is width. Okay, so yeah, so this is going to be limit y, then no. Oh, but this should just get me up to 0. That doesn't make sense. Up to 0. Limit x. Oh, sorry. This is a mistake. Going left, I should just go to 0. 0. Going right, I should go to the limit y. Hopefully that will make more sense. Let's look at my beautiful animation. Look at this beautiful thing. Look at this. Look at it moves. So beautiful. The speed is actually inconsistent, and I'll probably get to that, but it's like it should be moving in a much more strict thing once I actually implement some logical tests for the timing instead of just trusting the update loop to run at a certain time. Right now it's running at whatever rate, whatever refresh rate happens, and there's no guarantees in here, but it does work, and I'm having an animated shape, so it looks good. So let's store these things I added. So what did I add? So so this is cleaned up geometry files and added an animating example. Okay, so this looks pretty good. I am pretty happy with that. I'm pretty happy. What's next? Let's think about this. How's everyone doing today, by the way? Let me know in the comments what you think. Like I always say, this is streamed on a bunch of platforms, so if you respond, I can probably get your comment happening on stream. Hopefully whatever you're watching makes sense. If not, feel free to ask me questions. I can definitely answer on the C++ side or why I'm doing stuff side. I don't know if I can answer on everything to do with, oh, did I not use limit x? I didn't use limit x, which is, they just happen to have been the same number. Really, but that's just random, so this should be limit x. They're the same number, so it looked correct, but it was not correct code-wise. Okay, so that moves. Let's make it a bit slower, and all I need to make it slower is just change the offset to half of that. Okay, so that's a slower animating rectangle. Good. Okay. So I have that, and I have the color. The problem that I have now that I need to solve, and now this comes from my lack of understanding in OpenGL. Like, for example, now I set the color. We would need to learn how to do this, right? So that now I just set the color, and if I add more, like let's add another rectangle. Let's ignore this beautiful animating code as much as nice as it is. Let's just have let's just draw a fixed rectangle. Yeah, because the animation look nice, but doesn't matter. Yeah, so I'll just draw the static rectangle for a second. There's a comment here from Orzel saying they got a foot of snow where I'm at yesterday. The sun's now the sun's out and melting it. Oh man, snow. That's crazy. Where I am, I don't think they can't. Maybe there's snow for like an hour, an hour every 5 years or something. But it's snow. That's fun. I don't know if you shovel the snow yourself where you are, or do you have to handle it somehow? It sounds difficult. I've only lived in New York where they had snow, and it was really fun the one day where it's actually snowing, but once it becomes icy, it's just I just always felt like I was tripping on it, and I had to buy like these shoes that stick to the snow better or to the ice better, and I always felt like it's such a hassle. But the actual snowing bit is beautiful, like yeah. I'm sorry. I hope you're not stuck in the snow. Is my point. Okay, so what do I need to do? The part I want to understand is, what's usually the way to do this? Because I'm guessing, I don't know if I'm right about this, but I'm guessing it's not. I'm not gonna send a different program for each shape, right? When I'm batch rendering this. Okay, let's go back to. Right, so let's start with a few different things. So, okay, thank you. Now I have a question about how to chain multiple shapes. Let's say I have a few rectangles, each with its own color, own gradient, etc. What is the best way to render them next to or on top of each other? Would I use a different OpenGL shader program for each separate shape? Okay, so this is saying you should use a single shader program. Leverage vertex attributes and uniform variables to pass per shader. Your vertex shader to include a color attribute for each vertex. Okay, let's specify color per vertex. Okay, so that's interesting. So they're saying I should just output this in the shader. Update your vertex data structures. Okay. So they're saying I should create a vertex with a point and color. Okay, I like this. So they're saying, yes, so that definitely looks good. So what they're saying is, when I create the what I call the shape class, it's more like a drawable shape, right? Like it's not like there's no geometry here really. What this is like this is more like data we're stacking. So yeah, I think he actually says something pretty correct. So yeah, so what I could do. Yes, and I think it's good. So I think what I'm gonna do. Okay, so so that sounds great. So what I would suggest is instead of calling it a shape class, we can call it something like geometry or geometry geometry draw, where you interact with it in some stateful way, like or let's call this like a painter or even renderer, something like this. Renderer O2 R equals renderer R add rect car set color get white color add rect add other rect or set gradient get gradient this is the correct A. Oop, sorry, 1 second. 1 second.